On Deep Learning in Practice 2, Transfer Learning Projects. I'm Anis Kuba and I will be your instructor in this course. This course is the second episode in the series of courses Deep Learning in Practice. The first episode dealt with basic concepts of classification projects and how to build a dataset and prepare it for a deep learning project. Let's first review what was presented in the previous episode. In the first course, we first presented how to run a basic deep learning project on a simple cut and not cut dataset. We also introduced how to load images from a dataset folder and visualize them using matplotlib. Third, we demonstrated how to create a simple CNN model with convolution layers, pooling layers, and output layers. And we explained the difference between the feature extraction layers and the classification layers. Besides, we showed how to train a model and conduct a basic evaluation. The problem of overfitting was also introduced, and we discussed how and why the training accuracy would be higher than the validation and test accuracy. In the second part of the first course, we have demonstrated how to build a dataset efficiently from scratch, starting from data collection, then how to clean the data and remove duplicates and avoid having a bias on the trained model. We also presented how to build an HDF5 dataset and how to create the distribution of images and analyze it. In addition, the course showed how to split a dataset into a training, dev, and test dataset and how to create binary labels for the different classes. Finally, we trained a simple CNN model on the created dataset and we conduct a basic evaluation. So the example of demonstration of the previous course was a vehicle type classification, which contains 7 classes of vehicle types, including bus, sedan, bicycles, motorcycles, and some other classes. In this course, we will build on the previous course, and we will use the same dataset to show how we can improve the training performance using transfer learning on the same dataset. So what was the problem that we faced in the previous course and that we attempt to solve in this course? Well, in the previous course, we have built a convolutional neural network manually from scratch and we have trained it on our dataset. The problem was that the accuracy of the validation dataset was much lower than the accuracy of the trained dataset. And this is known as the problem of overfitting. One of the issues that lead to overfitting is that the convolutional neural network itself, which may not be optimal for a particular dataset. The design of an efficient convolutional neural network is very challenging and requires a lot of trial and error. In addition, starting a training from scratch usually leads to longer training times for the CNN to converge. So what would be the solution? Fortunately, in the literature, there has been a lot of CNN architecture and models proposed for classification and were proven to be efficient. So the idea is to reuse them to train our custom dataset. That is a first good step. But even better than this, there also exists instances of these deep learning classification models that were pre-trained on large datasets such as the ImageNet. This means that the initial weights of the networks were trained to recognize a lot of features, and this is better from starting from an initial random state. Fortunately, it is possible to start training a network from a pre-trained model, and this concept is called transfer learning. This means we transfer the weights learned from a previous model to train another model. In this course, I will show you how you can develop classification project using transfer learning. Let's look at the objective of this course and what you will specifically learn. First, you will learn the main concept of convolutional neural networks such as convolution operation, pooling, and padding. Then you will get an overview of the most important and state-of-the-art architecture used in classification project, such as VGGNet, Inception, Exception, ResNet, DanceNet, MobileNet, and EfficientNet. This will give you a solid understanding about the main algorithms and models and will allow you to choose among them for your particular project. Then we will demonstrate to you how to perform transfer learning for existing pre-trained models in TensorFlow 2 and Keras. You will have the ability to train your custom dataset on any pre-trained state-of-the-art classification model. I will also demonstrate to you several tips and hints to efficiently drive your deep learning project. As a matter of fact, when developing a professional deep learning project, it is important to have the ability to save your best model during the training. In fact, as the training goes, the validation accuracy will be increasing and decreasing at each epoch. Therefore, it is a good practice to save the checkpoint with the highest validation accuracy obtained during the training, as it is not guaranteed that the latest epoch will give you the best model in terms of the validation accuracy. This also represents another advantage, which is the best saved checkpoint model can be used as a starting pre-trained model to further train the models for more epochs, with maybe different configurations and settings. Monitoring the training is another practical task that someone wants to do during the training. In fact, usually training takes long time, and it would be great if you can monitor the progress of your training through the internet while it executes. You will learn how to do that in this course. Finally, when you develop an AI application, you should not train your dataset on one particular state-of-the-art deep learning model, but you need to try different models, compare between them, and choose the best model for your particular application. In this course, you will be introduced on how to manage a deep learning project with different classifiers and how to compare between them and select the best model for your deployment.